Hello students, welcome back to this lecture series of mathematical methods in physics. So in this lectures we are going to discuss Fourier complex integrals and its mathematical expressions, that is f of x is equal to 1 over 2 pi integrations from minus to plus infinity e raised to minus I mu x into d mu, and again integrations from minus to plus infinity f of t e raised to I into mu t into dt. Okay, so this is a mathematical expressions of the Fourier complex integral. So we are going to prove this statement, mathematical statement, by using the Fourier integral formula. So before that, if we consider this f of x is odd functions, okay, and if we take the integrations of this f of x or the limit minus to plus infinity, then it is integrations is equal to 0. Okay, if this f of x is odd functions. So these conditions we are going to use in this expressions for solving these expressions. So and another equation, that is Fourier integral formula. So we know the Fourier integral formula, that is f of x is equal to 1 over 2 pi integrations from minus to plus infinity, and again integrations from minus to plus infinity f of t cos mu into t minus x into du into dt. Okay, so this is this is equation first and this is equation 2 that we are going to use in this derivations. Okay, so here this f of x I am going to consider f of x is equal to sine mu into t minus x. So this is the odd functions. Okay, and if I take the integrations of these odd functions, so that is equal to 0. So we can write 1 over 2 pi integrations from minus to plus infinity. Okay, this is f of x. Okay, f of 1x, again integrations from minus to plus infinity, and f of t sine mu into t minus x du into dt. Okay, so if this functions sine u into t minus x, this is odd functions, then this total multiplication with the f of t, so this total functions may be odd functions, and its integrations is equal to 0. Okay, so it is equal to 0. And next step, that just multiply eta to these expressions. So we can write eta over 2 pi integrations from minus to plus infinity, and again integrations from minus to plus infinity f of t sine mu into t minus x into du into dt is equal to 0. Okay, so this expressions f1x, that is equation number 3. Okay, so now I am going to use these two equation, that is equation number 2 and the equation number 3. F is a function of x is equal to 1 over 2 pi and the integration over minus to plus infinity, again integrations minus to plus infinity f of t cos u into t minus x du into dt, and here this expressions that for the f1x is equal to eta in our 2 pi integrations from minus to plus infinity, again integrations from minus to plus infinity f of t sine u into t minus x into du into dt is equal to 0. So this two equations, that is 2 and 3, I am going to add these two equations. Okay, so f of x is equal to f of capital F, okay, is equal to 1 over 2 pi, just add this 2 and 3, 1 over 2 pi integrations from minus to plus infinity f of t cos mu into t minus x du into dt plus eta over 2 pi and integrations from minus to double integrations from minus to plus infinity f of t sin mu into t minus x du into dt. Okay, so these two equations just add or take out these commons, that is 1 over 2 pi integrations from minus to plus infinity, double integrations from minus to plus infinity f of t, and you can write cos u into t minus x plus eta into sin u into t minus x into du into dt. Okay, so these expressions, we know the cos Euler formula, that is e raised to I theta is equal to cos theta plus eta into sin theta. Okay, so this trigonometric form we can write in the exponential forms. So this equations becomes 2 over pi integrations from minus to plus infinity f of t and e raised to, now here theta if we compare, so this is we can write theta is equal to ut minus ux. Okay, so it is eta into ut minus ux into du into dt, and this exponential you can write capital F x is equal to 1 over 2 pi integrations from minus to plus infinity, double integrations, and f of t e raised to eta into mu x, mu t, and e raised to minus eta into mu x du into dt. Okay, and it is right 1 over 2 pi integrations from minus to plus infinity e raised to minus eta u into x du, and again integrations from minus to plus infinity f of t e raised to eta into mu into t dt. Okay, so this is a complex form of the Fourier transforms. Okay, so also if we change this limit, that is 0 to infinity, then it is 2 over pi 0 to infinity e raised to minus eta into mu x du into 0 to infinity f of t e raised to eta into mu t dt. Okay, so this is another expressions, mathematical expression for the complex form of the Fourier integrals. Okay, so let's stop here. Next lecture we will discuss